Good morning, everyone. Let's see if I can share my screen here. Show. There we go. You are at the second day of our Overcoming Installation and Sales Challenges for residential replacement heat pump water heaters with Tim. And let's see. We're trying to start right on time here. Where's my audience? There we go. All right. I'm Katie from the Lighting Design Lab. We're part of Seattle City Light. I don't think I mentioned last time. Not everybody realizes that. And then if you haven't taken a class with us, for webinars, you're all on mute, but you can submit any question anytime through the chat, and we'll get that answered. This is being recorded as soon as I came on, being awkward. I might clip that in the one that we post online. It's being recorded so you can go back and catch parts you missed, or if you have to leave it early, finish it out. And there's a little survey at the end of class that we would love you to take to give us some feedback on how we can make things better or bring you some different information. Coming up, we're doing a couple of case studies in the next couple of months. One on the Miller microgrid at the Miller Community Center. It's going to be really interesting to see how that's coming along. It's working. And then a presentation on a multifamily building in Seattle that's done heat pump water heaters for, oh my gosh, now I can't remember, maybe 60 units. It's a big project. And then in between there, we've got for the first time an HVAC systems testing for energy efficiency, which is going to be really important for any of you who are going to have to deal with building performance standards. So a good intro to that. And just a reminder, if you were here, if you got to attend last week's first part of this webinar, the program implementer for the midstream rebates for heat pump water heaters is Energy Solutions, and that's their contact info there if you have any questions. And let's see, everything feels very awkward right now. I'm going to change my presenter over to Tim, and Tim and Diane are going to take it away. All right, Tim, did you get that?
I did.
There he is. Good.
Perfect. Let's see here. Okay. Good morning, everyone. Thank you for joining us again today, a week later after our presentation on sales and marketing of heat pump water heaters, technology and that information. We're going to repeat some of those early slides just as a refresher when I start in today, but it'll get more into the installation challenges in the second section of our presentation today. Again, my name is Tim Abshire, and I mentioned this previously, but I've spent my career working in utility business, beginning with Northwest Natural Gas. I went through the, basically right out of college, right through retirement with them, and currently work for DNR International, doing training for heat pump water heaters. I'm a subject matter expert. And also, we offer continuing education credits. I want to mention this for the state of Washington. If you're interested in those continuing education credits for this course, you're eligible for 3 hours from the first course last week and an additional 3 hours for the course this week. So if you're interested in that, reach out to Katie, let her know, and we'll get the paperwork together and get it off to you. So if you joined us last Tuesday, if you joined us last Tuesday, as I mentioned, we're going to repeat some of these slides. The first section is just a few slides that we just want to understand, again, who you are and a little bit about the technology. So let's move into a little bit about our company. DNR International is headquartered in Silver Spring, Maryland. We have that's where our headquarters is. We have people throughout the United States working on behalf of the company, doing various kinds of tasks, including training for a whole variety of energy efficiency products. DNR really covers, helps our clients understand how to transform the energy market, primarily in transportation and buildings. And we focus on bringing new technologies to the market and creating long-lasting change. These are some of our customers. I read this morning that we picked up the Department of Energy, or we're working very closely with the Department of Energy on the Advanced Water Heater Initiative that I spoke to briefly last week. That's that initiative that's funded federally, and it's moving across the country in their application and initiation of these utilities and other interested parties that would be interested in heat pump water heaters and the transferring standard efficiency to high efficiency using heat pump water heating technology. These are some of our other clients, Northwest Energy Efficiency Alliance, who I spent some time working for and really was able to impact the Pacific Northwest, including the state of Washington. The Environmental Protection Agency, North American Electrical Distributors, Hardy, Design Lights Consortium, and the Energy Trust of Oregon. So again, if you remember, we did a Slido poll, and in this particular case, we're going to repeat the Slido poll that we had early on. So if you can take your phone and scan this QR code, we will move on to the first slide. And it would be just kind of understanding the knowledge. And I think last time we were about 50-50 on intermediate and novice, but we want you to understand where you are in terms of installation. Okay, so we're going to be focused on installation challenges today. Think about answering this question in that term. Would your experience in heat pump technology be at a novice level, an intermediate level, or an expert level? I recall last time we had a few experts, but couldn't tell you how many. It's just a percentage. So mostly novice at this point, intermediate, some 33%, oh, 50%, oh good. So we have some people that have had some experience with it. All right, we're at 50-50. So novice and intermediate seems pretty close to where we were last time. So let's take a look at the next poll. And it is, I have participated in 0, 1 to 5, 6 to 10, or more than 10 heat pump water heater installations. 0. Hope that this training will open your eyes to the simplicity, really, of heat pump water heater installs. They're very, very, very similar to just a standard electric water heater, but there's a lot of installers out there that are afraid to use them just because there are some differences. So 100%. So we're going to be talking to you all fresh. This will be all good information for you. And lastly, I think that heat pump water heaters are overrated and underperform. Okay, for some households, or awesome and a great investment. Awesome and a great investment. Good. Anybody else? Okay, we'll move past this section now and on to kind of what we're going to be covering today. So this is the roadmap, basically, for what we'll be talking about. And it's my aim that following this training, that you'll be able to understand how a heat pump water heater works. This will be the repeat section. Explore space and location considerations for heat pump water heaters. Options for managing condensate. and then sizing a heat pump water heater. That also will have be a bit of a refresher, but it's really critical, and particularly when we're talking about serving families that have an expectation of savings and what have you. Switching from natural gas to heat pump water heaters. That's what we'll wrap up with. Okay, so the first section is how does it work? We're going to talk about the heat pumps as the new application for water heating, which really isn't new, as you know from last time. Understanding the science and how it works, and then the operating modes. So this is a little different slide. If you recall, last time I had this picture of this 1927 Kelvinator on the screen, and that was one of 6 different photos. In this particular case, I just wanted you to understand that heat pump technology is essentially, heat pump technology for a water heater is essentially the same heat pump technology that they use in refrigeration. The difference is only that the refrigerant runs in reverse. So on the left is that 1927 Kelvinator, and it housed the heat pump right on top of the cooling compartment. So it would draw air from the inside of the refrigerator, and the heat pump, the refrigerant would capture the heat that's inside there and cast it out into the byproduct, or the warmer air, into the ambient space around it. As the design improved, then they moved the heat pump from the top of the unit to underneath the unit. Some of you imagine yourself standing in front of the picture on the right, the 2022 Kenmore. You've got the doors wide open and you're wondering what your next snack will be, right? As you stand there, you're filling that cooling compartment with warmer air that's in the ambient space around it. And we've all experienced this, that when you're standing there looking, wondering what your next snack is, you feel the warm air flowing out of the bottom of the refrigerator on your feet. That's not the heat that's coming from the motor that's housed under the refrigerator. It is actually the heat that was introduced into the cooling compartment when you were selecting your snack, that the heat pump was able to extract. When the heat is removed, what's it leave? Cold space. So that's how the refrigerant works. And imagine on water heating, instead of extracting the heat from the cooling compartment, it's inputting heat into the water tank. So it's just the same thing operating in reverse. So the question is, well, look at the center picture. It's a 1960 GE refrigerator. It was popular in color with copper tone, avocado, and harvest gold. And maybe some of you have those, remember growing up and having those refrigerators in your kitchen. Well, I always ask installers when I'm speaking with them, showing these pictures, I just said, when was the last time you changed the compressor, gosh, I can't say the word, compressor in your refrigerator? Some of you may have had that old avocado or harvest gold refrigerators, as I mentioned, growing up. And some of you may still have them in your garage, or your parents may have them in your garage, still keeping their beer cold or the soda pop cold. And it's really reliable. That technology is really reliable. You know, I looked under the refrigerator when I was going around visiting installers, being with installers, and we'd go to customers' homes, and I'd see these refrigerators in their garages, and underneath them, the cooling coils are just completely covered with dirt, but they're still chugging along, plugging away. So the technology back in 1927 to 1960 to 2022 is all the same, and it's exactly the same for the heat pump water heater. So today, you know, their heat pumps are used in a variety of residential, commercial, and industrial applications. We talked about the clothes dryers and some home heating and cooling, ductless heat pumps, as I mentioned, swimming pool heaters, and of course, you know, regular residential water heating. So here's the video again. I'm going to show you. Specifically, I want you to, again, apparently some of you may have not have seen the cotton ignite in this piston. So I'm hoping that perhaps it'll run smoother this time. That's specifically what I'm looking for you to note. As you compress a gas, the portion of the video where he does this will ignite the cotton that's in the bottom of that piston. So it's simply compressing the air inside that piston will create the heat. So I'm going to, I have to do this in kind of a crazy way, but I'm going to start this and start this and try to do it at the same time. Let's give it a try.
Cold here attracts the heat. Hot here dumps the heat. That's right. This is the part that doesn't make any sense. Right. How can you have something that is both colder than the warm inside air, but then hotter than the hot outside air? The same thing is both things. Well, if I can compress a refrigerant, it has no choice but to get. Any gas will get hotter if you compress it. This is a perfect example here. This is a little sample unit. Now, this is just filled with air. You can see there's a little piece of cotton right here. Whoa, air. So not even refrigerant, just air. It's a gas. So air works the same way. What'll happen is we'll compress that air and get it so hot we'll get to the flash point that it'll light it up. I don't believe this. Watch this. I don't believe this. All right. It wasn't hang on a second, but it helps you understand that if we compress a gas, it's directly proportional to the change in pressure too. It'll get hot more. So that's what this is doing. That's right.
Okay, so hopefully that worked. It wasn't synced up exactly, but you got the idea. So the magic about heat pump technology is just that as you compress, whether it's an oxygen or the air that you're breathing every day, or if it's a refrigerant, if it's a gas, it gets hotter when it gets compressed. So we're going to talk about the cycle of the heat pump water heater and show you specifically where that is, where that's occurring. So again, the heat pump water heater cutaway here is basically the top 18 inches is a heat pump, and the bottom, whatever it is, 3 feet, 4 feet, is an electric water heater. If you took the heat pump off, that's exactly what you would have, is an electric water heater. So what happens is the fan on top of the water heater draws in the ambient air from around the space that it's located. It needs to be between 36 and 120 degrees and flow across that evaporator coil. That evaporator coil here highlighted in red. It contains a refrigerant that has that very, very low boiling point of minus 50 degrees. So the heat that's contained in that ambient air that blows across it, even if it's only 36 degrees, will be absorbed by that refrigerant and will convert that refrigerant from a liquid to a gas. Then the refrigerant will pass through and go into the compressor. That's where just like the piston, the compressor compresses that gas and will heat it up to 180 degrees, similar to what we just saw in that video. Although in that video, I think I forgot to mention this, is that cotton will ignite only once the temperature reaches 410 degrees. Here, it's all directly related to how much compression you put on that gas. So here it's limited to 180 degrees. So it goes from minus 50 to 180 degrees just through the process of that compression. When the gas then is cycled, the gas is cycled through the coil down to what's called the condenser coil. And there it transfers the heat from the hot gas inside the condenser coil to the water at about 300 to 350% efficiency generally. It can go as high as 400. So at no point did the heat pump create a new source of heat. Instead, it just moved heat from the ambient space, heated the refrigerant where it was absorbed by the refrigerant, and then it was compressed, causing it to heat up, and then cycled down to the condenser coil where the cold water rests in a water heater, and then it transfers that heat. So that's a simple, basically a very simple process. So there's 4 operational modes on a heat pump water heater. The heat pump only, we talked about this again last week, but it's the most efficient mode by far. It's why people buy them. It's the mode that you want to operate your heat pump water heater in if you're interested in creating savings and efficiency. So it's really the ideal. This is where the sizing comes into play. It's very ideal for a household that has the capacity and yet still can depend on the heat pump to do the recovery. It is slow. Now, we talked about this also. You're exchanging speed for efficiency when you use a heat pump to heat your water. So a standard heat pump will do about 9 to 12 gallons per hour compared to a standard electric or gas, which would be 22 to 24 gallons per hour reheated. But the efficiencies are where the difference lies. Hybrid mode, okay? This is the default mode, and it's the heat pump. It's the mode that the heat pump would be set in right out of the box. In the hybrid mode, it primarily means that it's heating the water in the heat pump mode first, and then if you're not able to meet the demand of the water being drawn out of the tank inside the house, if it's not able to keep up with that demand, it will switch over to the electric elements and reheat the water until the demand is met. The benefits on this are that it's a blend between the heat pump and the electric elements, so it'll keep up with the performance of an electric water heater. So we talked about this last week, but when we talked about the first hour rating, a heat pump and an electric water heater essentially have the first hour rating, but the same first hour rating in terms of how much water it'll heat up. But the question for us is always, do we want to use all the energy resources the water heater has in the first hour, or do we want to plan for that capacity initially and having the water heater stored up the amount of water that you would use during any particular hour of the day when you use it the most? So hybrid mode can still operate pretty efficiently. Like I said, it comes out of the box that way, but you do lose some efficiency. Electric only mode. So if you select electric only mode, the heat pump becomes an electric water heater. That's what it does. It just shuts the heat pump down. But if you're expecting a lot of guests, and you can manually put the system in electric mode to provide maximum recovery rate. And that's maybe only temporary, but nonetheless, you can still keep up with the demand that might be increased as a result of having company. Some brands will automatically revert back to the hybrid mode after 48 hours. So you have to keep that in mind with whatever, depending on the brand that you purchase. So the other thing that's important to note on this particular mode is that it is the backup to the heat pump. So this mode, if there's ever a problem with the heat pump itself, if it malfunctions or doesn't work, it will automatically flip over to the electric only mode. It'll also flip over to the electric only mode if there's a problem with the condensate, whether it's a plug in the condensate pan or condensate in the condensate drain. It will back it up and trigger the heat pump to flip over to electric only mode. Thirdly, it will flip over to electric only mode if the temperature drops below the minimum setting, which is 36 degrees on most water heaters. I will tell you that on A.O. Smith, excuse me, on A.O. Smith water heaters, heat pump water heaters, it will flip over to electric mode at 42 degrees. That's just what their calculations deemed as the appropriate temperature. But all the other brands, I think it's 36 degrees. So the drawback to this is that it is the least efficient of all the options for water heating when you're talking about comparing it to heat pumps versus the electric only mode. Lastly, there's vacation mode. You know, we said that basically this is just set when you're going away. You can set it for an extended period of time when the hot water is not needed. Vacation modes vary by brand. Some of them can be set up for 99 days, while others only 14 days. But nonetheless, it's just keep the water about 65 degrees while the water heater is sitting idle. Some brands will automatically switch over to hybrid mode 1 day before you return home. It's just something that they have built into the motherboard that you can set up and coordinate with, or not coordinate, but just establish with your water heater. On one brand, Rheem, will you can do it remotely. You know, use your phone and have an app that goes with it, and you can turn it from vacation mode to heat pump mode, you know, a day before you get home. So the key takeaway to this, again, is simply that heat pump technology is very simple. It's reliable, it's tested and proven. So I'll just ask if there's any questions about this particular section before we move on to the real installation challenges that we'll be facing in the field. Does anybody have any questions? You could put them in the chat, by the way, and Diane will call them out for me as we go through this. Hopefully I'll be able to answer them all. Anything that you can see, Diane, that people might have a question about?
Yep, one just came in. It says, what is the penalty of having heat pump water heater taking heat from inside your home?
Very little. So it's just like, here's the example that people use when they try to demonstrate this. There's one exception, and we're going to talk about this later in the presentation, but the heat pump water heater only runs for, the compressor only runs generally between 5 and 7 hours a day under normal circumstances. The impact on that on your HVAC system, what you're getting at, I think, is that your HVAC system is going to have to make up for that heat that the heat pump water heater has taken out. Well, the heat pump water heater is using it at 300% efficiency. Okay, so it's not using a lot of energy, even in a cooler space. So you're not going to be penalized too much. But what a good comparison to that would be, in the summertime, your refrigerator is kicking out that warm heat from underneath of it. You know what we talked about, you can feel it blowing across your feet. What's the impact on your AC? You know, you have very little, I mean, literally, I don't know of any occasion where the refrigerator in my home has caused my air conditioner to come on. And that's basically the same is true for heat pump water heater. It only uses 300 to 300, or excuse me, 550 watts of power. So it's not a big unit. So it's just not taking in a lot of air. Now, you could be impacted if the exhaust, I'm getting ahead of myself here, but if the cool air exhaust, and once you've extracted the heat out of the ambient air and you're blowing it away from the heat pump water heater, if that's hitting a thermostat, then we have a different conversation, because that will trigger your heating or your cooling to come on. So your heating to come on or your cooling to shut off. That's what I should say. So, but I wouldn't ever be concerned that it's going to impact my HVAC system at all, particularly just because it just doesn't use that much air. It's unimpactful. Anything else?
Nope.
Okay.
That's it.
We're going to move on now. Get into the reason why we're here today, I think, is really to learn a little bit about what kinds of challenges you might see in the field for heat pump water heaters. So in this section, we're going to talk about the size of the room and then louvers and ducting options. So heat pump water heaters need to have a supply of warm ambient air for the heat pump to work efficiently. And we talked about the temperature range being 36 to 120. So I use this as a basic number, but basic numbers, but you should refer to the owner's manual what their highs and low temperature settings are set at. I know that there's some that are set at 110 on the high end, and I have already mentioned 36 on the low end. So there's a whole range there. But typically, if your heat pump's in a standard place, even like an unheated garage, you're going to fall within this range, perhaps year round. I know I live in Portland, you're in Seattle, so our temperatures, you know, it's pretty rare for us to get extended cold stretches. But if you have an unheated garage, you could be impacted. It'll flip over to the electric elements, perhaps, in the coldest time of the year, but it's not the standard practice. But it does need to have warm supply. So if you have an area where it can draw air between those temperatures, you should be in pretty good shape. And there are a number of ways to achieve this. So not only do they have to have a warm supply of air, they have to have a room that's a minimum of 720 cubic feet of space. Some installers, or excuse me, some manufacturers say 700, some say 720. I'm going to err on the larger size, just because I think it's safer. 720 cubic feet of space is required to have a heat pump in a room without providing a proper means for air exchange. Okay, remember that the heat pump extracts the heat from the ambient air around it, and what's left after the heat's removed? Cold space. So operating a heat pump in a small space without the proper air exchange will cool the room, and the heat pump becomes less efficient and could eventually default to the electric elements. That's what you don't want to have happen. We talked about our goal is to get that heat pump to do most of the recovery on the hot water. So garages or other open spaces are ideal. But let's say you don't have 720 cubic feet, but you have a space where the water heater is currently located and you want to put it back in the same location. You can compensate by adding louvers, louver doors, or ducting, or both. Actually, we're going to talk more about a lot about the combination of louvers and ducting working together. So let's start with louvers. If the water heater's in the room that's smaller than 720 cubic feet, louver doors are a pretty good solution, or installing louvers in the walls are an option. But louvers have a standard by which they're measured called the net free area. And they're generally listed on the louver at the time that you purchase it. The net free area is the open area that exists for air to pass through. So the range of free area in most louvers will be between 35% and 60% of free area where air can actually move back and forth. But that leaves 65% to 40% of it obstructed. So keep in mind when you're purchasing a louver, it isn't the square inches that you're concerned about, it's the net free area, the amount of free area that air can pass through. The required net free area varies by manufacturer. So how big a fan they have and some other factors take into account the amount of net free area that's necessary. And the room size will also factor into the net free area requirement. So example of different manufacturers, Bradford White, for example, specifies that louvers must provide at least 240 square inches of net free area. So what does that translate into a unit? You're going to have to refer to the setting or the standards that are posted on the unit, the louver itself. A.O. Smith, so Bradford White's 240, A.O. Smith requires 336 square inches. So 96 square inches more than Bradford White. So it's really important to read your installation manual if you're putting in a heat pump water heater in a small space, that you provide ample space for the air to pass through to provide the heat pump with its ambient supply, or to remove the cold air that's the byproduct. Another option when faced with small spaces is ducting. So all manufacturers have this option available, and they sell the duct kit that attaches to both the intake and or the exhaust grill. Okay, so if you look at this water heater on the left, you see the ambient air will always come in on the top and the exhaust will always go out the side. So those do not have to be installed together. If you just need more ambient air, you can just put the vent in from another location and supply it on the top of the unit. If you just want to get rid of the exhaust air, you can use just the regular grill, and you don't have to install the ducting on the intake side, but just duct it out through the exhaust. So homeowners can select either of those options if they want. But you can also install them both inlet and outlet, as you see in the example on the right. This is an 80-gallon water heater. They're just showing the door height. But you see the intake air on the top of the unit coming in from a room that's adjacent or outside or wherever that is. And then the exhaust air going out the side into another space somewhere else. I'm not sure what's on the other side of that wall. Could be going outside, or it could be going into another room. I don't know. But you can, in this case, when you have inlet and outlet ducting, there's no requirement for the minimum room size. The 720 goes out the window because you're providing your inlet air, your ambient air from one space, exhausting the cool air to another space, so it'll have no impact on the operation of the heat pump water heater if the room is small. Okay, so in this slide, this is one manufacturer's solutions for addressing small spaces. So this louver's ducting, or the combination of them, is a good option for achieving the required air exchange if you don't have the space. And there are a myriad of configurations that installers can use to find solutions for providing warm air, warm supply air, and managing the cooler discharge. So manufacturers, like I said, they all have something similar to what you're looking at here in these pictures, but they're not necessarily the same for all manufacturers. They do represent solutions that are very similar, however. So refer to the installation manual for the manufacturer of the unit that you'll be working with to confirm the louver and ducting requirements. I always got to say that because there's no standard. It all depends on the venting and the fan motor, and all those things come into play, the room size. So let's look at these. Let's go to picture number one. You'll see there that in that door, there's no louvers and there's no ducting on the water heater. And you go down, it'll say enclosed room, then it says 700. So that's the minimum cubic feet for having a water heater, according to this manufacturer, in a room without having to accommodate a fresh supply of air or discharging the ambient or the cool air. So that installation would work just fine as long as the room meets that 700 cubic feet requirement, right? But let's look at the second slide, or second picture. Room size is now 300 cubic feet. So when one louver is installed that meets the manufacturer's net-free area requirement, the louver should be installed at the location where it is close to the top of the water heater. Both the inlet and the outlet vents are in the tops, just in that heat pump section of the water heater. So having the louver located near them allows the air to move freely. In slide number 3, or picture number 3, the room size is now 120 cubic feet, so considerably smaller. So in this case, this manufacturer, it requires 2 louvers to be installed. Install 1 louver just over the top of the water heater to supply the ambient air, and the other one where it is close to the center of the heater's top shroud. So the top 18 inches of the heat pump water heater is covered with a shroud, and you want to enclose it close to the top of that, or the middle of that. The idea is that you want to be able to aim the cold air discharge at the lower louver. So again, keeping the louvers near the top of the water heater allows both the ambient air to come in and the cool air discharge to move out freely. Anytime you can target or aim the direction of that exhaust at a louver, you want to do that, just because any buildup of cool air in that space can impact the heat loss that comes off of the water heater, right? In picture number 4, here we see a duct, and in addition to the louver. In this picture, the duct serves as an inlet duct. Okay, it's coming in on the top of the water heater. So that's the inlet duct. And it's bringing in a supply of ambient air from a space, another space, an adjacent room or outside. But this single duct installation could be attached to the outlet side. So this doesn't have to be just, this is an example of an inlet duct, but if you read the note there, it says also you can use it for an outlet duct. So it doesn't necessarily have to be the inlet side that you're attaching the duct to. It could just be on the outlet side. And what happens then is the louver provides the ambient air. As soon as you're starting to blow air out of that room, you create a negative pressure, and it'll draw air through that louver to supply that water heater with an ambient supply of air. Now, if it's a inlet duct, as it's depicted here, then ideally you want to aim the discharge grill, which is on the side, at that louver. Okay. Anytime that you have a single duct, you want to, when one duct adapter is used, locate the louver close to the non-ducted grill. So this is an example of where that might happen. Inlet duct coming in from adjacent room, you want to aim that louver as close, you want to aim that water heater discharge air as close to that louver as you can. And then picture number 5. This is just similar to that example I showed you a moment ago, in that where there was ducting inlet and ducting outlet. So all of a sudden, you're going to supply air from one space, you're going to discharge air to another space. You don't need there's no room requirements, no minimum space. You can put it in a small closet wherever you want and provide ducting as its source of ambient and discharge air. So here's some examples of some of these installs. So here's some unvented installs. Now, in spaces that clearly exceed 720 cubic feet, ducting is not usually needed. So installations like these that we're seeing here really serve as the low-hanging fruit for consumers, and they offer the lowest price installations. So garages offer open space for installs, and ducting is unnecessary. You see here on the picture on the left. The one nice benefit to this is the cool discharge air can offer some relief on hot summer days. It keeps the garage temperate to a degree. But it isn't an air conditioner for the purpose of cooling that garage, because it just doesn't operate that many hours a day. Like I said, 5 to 7 on average. In the center picture, you see a laundry room. And a lot of people prefer those kind of locations. And the reasons why is that the discharge can help keep that laundry room cooler when the dryer and the washing machine are running, because they generally deal with hot water, and the dryer is hot air. So you have a temperature increase in that room. Typically, that's kind of when you seal it off and shut the door so you don't hear the machines. It'll warm that room up. Well, the heat pump then can keep that room comfortable. The other thing about it is that the heat pump serves as a dehumidifier. So in a laundry room, you tend to have more moisture in the air just because you have the washer dryer running. And what heat pumps do is they remove the moisture from the air through the condensate that they collect. So a lot of people like that type of installation. And the picture on the right, this is an interior closet. Now, I'm not sure what size that room is, but you have to look closely. But you'll see that the door is full louvered, completely louvered open. So it has, just by that alone, it offers you the adequate air supply and the ambient air supply, and then you can discharge in the same space. I'm going to go back for a second. I want to point something out. On this room, on picture number 4, where there's the inlet ducting, there is no code that requires a louver there if it's an inlet duct, okay? If you're driving, pulling ambient air from a space, you can discharge it into a small space, into a small room. The problem with it is that it reduces the temperature in that room, but you're not drawing the air from there, so it won't affect the efficiency of the heat pump, but you do lose, I say that kind of the heat pump itself, but you do have heat loss through the shell of the storage compartment. But just wanted to point that out because I didn't mention it. The louver door is a way to target and aim that cool exhaust out of that space so you don't have that heat loss, but it is not required. Okay. I wanted to point out one more thing on this slide. So yeah, again, just on this particular, on the slide on the right, you can see the full door is louvered. There's no venting, no ducting at all in this room. It's drawing its ambient air, pulling it through the louvers, and then it's discharging it in the same space, expecting the cold air to be blown to the outside. What I wanted to point out in this installation, on these two installations, both the center picture and the picture on the right, is that they're lacking a drip pan. Okay, so this is probably against code in most states. If you look at the one in the garage, you see that at the bottom of the water heater, it's sitting inside of a drip pan that if the water heater were to leak, or there was some problem with the condensate line that leaked, it would go into that pan and then it runs out through the condensate. So anyway, just to point that out, you wouldn't see this installed like this in any and pass code in most states that I know of. Okay, here we are back to inlet and outlet ducting. So let's look at the photo on the left. There are a couple of things that I want to point out here. First, the number one cost, or the number one barrier for sales of heat pump water heaters is the cost. So ducting will add cost to any installation. Anytime you can avoid ducting, you would do that. If you can simply put in a louver or whatever to try to drive the air into a different location. But if you have to duct it, it's going to add cost. So adding duct in the basements, and that appears that picture on the left is in a basement. That's not necessary in most applications. In this case, it appears that there's also 2 exterior wall penetrations that could create issues for a homeowner later. So I think if I were to see this water heater installed in a home, I'd have to ask myself, what other reasons are there that was ducted away? And it just doesn't make sense to do that. On the right, venting on an interior installation in a living space is more practical, but all options should be explored. I want to point out a couple of nuances to this picture. This water heater would require venting. It would not, excuse me, this water heater would not require venting in this scenario. Why? It's got a full louver door. So what they've done is they're eliminating the whatever issues that might occur inside that closet space by ducting it out or bringing in fresh air. So in this case, they're drawing warm air from the attic. That can improve the efficiency, but if the air temperature gets higher than 110 or 120 degrees, it might force the heat pump to shut down and default to the elements. So but you see this a lot in new construction today, where both the vent for the ambient air is coming from the attic, and then the discharge air goes right back up into the attic. So when the compressor's running, it's also discharging a cooler air into the attic to help modify that temperature, so it maintains its range, maintains an operating temperature within the range. You might also have to install an attic fan or some kind of exhaust fan to help manage those attic temperatures on hot summer days. Again, this is one of these things where you have to check with the manual for warm air limitations, because what you want to avoid are those electric elements turning on, and if it's drawing in 150 degree temperature air, it'll shut it off. One other solution is just to mention would be to push that cool ambient air into the attic. And in the Northwest, I've seen this a lot, where a whole subdivision has got heat pump water heaters, and they're all installed with drawing the air from the attic and discharging the air back up into the attic. Some homeowners will actually add a damper on the discharge air and in the summer they'll open that up and help cool that living space. So you can do that as well. It is essentially a small air conditioner if you think about it, but it doesn't, because it's not running all the time, all you're trying to do is leverage the air that it's, the discharge air that's cool whenever it happens to be running.
We have a question if you're ready for that.
Okay, go ahead.
Says, what is the energy penalty from locating the heat pump water heater in an unheated garage in a climate where it's often in the 30s and 40s outside in the winter? This person must be in Minnesota.
That's because you're from Minnesota, right, Diane?
Yeah.
Yeah. You would know.
Yes.
So what is the penalty? The penalty is that you reduce the efficiency. I can't give you if you're talking about a dollar figure, I can't give you that. But what you can do, I mean, let me say it this way. If you can save energy 9 months out of the year as opposed to 12 months out of the year, I would do it, because you may have to operate that water heater on electric elements for 3 months. That's what will happen if your temperature in that garage falls below that 36 degree temperature. It's not going to operate on heat pump mode, but every opportunity that it can, if it's set on hybrid, if you have that set on hybrid, anytime maybe you have a warm spell, a week of warm in the wintertime, and the temperatures go up to 50 degrees, then it'll flip back over to heat pump. So it just depends on the variance in the temperatures that the heat pump is exposed to. Ideally, you want to have it in a conditioned space where it's drawing air consistently between 36 and 120. Even better, the warmer that you get, the more efficient it will be. So ideally you want it 50 degrees or 60 degrees that's drawing air. But I know that's not going to be the case. But again, I'm going to go back to the impact is how much are you going to save? I have a slide in here later that talks about the savings that you should expect for putting in a heat pump water heater on a per person per year basis. So if you took out 3 months out of that equation, it is going to impact financially the operating costs from a financial standpoint, but you're still going to be saving 9 months out of the year. It's kind
I'd
of
put a heater in the garage to keep it at 50 degrees all the time.
yeah, perhaps that might be a good solution, or insulate the garage. And,
That's what we do.
Yeah. Oh, do you?
Mm-hmm.
Okay. Yeah. So it has to have those ambient temperatures to be able to function properly. And the warmer they are, the more efficient. So you'll have some impact financially, even if you're operating it in the garage 12 months out of the year, but the temperatures are hovering around 40 degrees inside that garage. It's not gonna be as efficient if it were drawing 70-degree air, for example. But it's still gonna be beating the heck out of your electric water heater options. We talked about 300 to 400% efficiency. You could actually get down to 275% efficiency, even 250% efficiency, and you're still going to see some savings. Okay, move on to this slide then. So the two pictures that I have on the left are examples of exterior water heater closets. You see a lot of these in California, remarkably. But this installation could represent any space inside the home. So I wanted to share this with you because it kind of speaks to how you address, again, small spaces with the combination of louvers and ducting. So both of these closets hold electric water heaters. And you might say, how do you know that? Well, because unlike gas water heaters, where you have to supply combustion air and venting, electric water heaters don't have that requirement. So we know that they're electric water heater closets because there's no louvers anywhere in it to provide combustion air, or there's no flue coming out of the top. It looks like there's flue on the one on the left, but that's not that's a sewer vent or something like that. That's not a flue for a water heater. It would be centrally located in the middle of that space. Anyway, because these closets are both less than 720 cubic feet, replacing them with a heat pump water heater, replacing these electric water heaters with a heat pump water heater would require that you modify these closets, including either louvers or ducting, or both. So let's look at a couple of solutions here. So on the diagram on the right, you see that a couple of examples. This could represent a solution for either an outdoor closet or either of these outdoor closets, or it could be also a space inside your house. And we're going to show you a case study next where this kind of solution is what they used. Sort of what they used. It's very similar to what they used. So in this particular picture, you see that the closets in the schematic, you see that on the left there are 2 louvers. They're 16 by 24. Those are supplying the ambient air from the outdoors. How do I know that it's ambient air? Because see the discharge is on the side. Okay, it's bringing air into the top of the water heater, and then it discharges out the side. The diagram shows that the outlet duct has an option of either a horizontal discharge path or a vertical discharge path. Either one of those are acceptable, depending on what the conditions are that are around it. So because of the negative pressure that when you draw the air out of that small space, it'll force air to come in, fresh ambient air to come into the space to supply it with ambient air for heating the refrigerant. So now this diagram could also be a solution for an indoor closet or a room. It's just a depiction of how the air supply and the discharge can occur in a small space, small confined space. So one reminder on this is that the net area of these louvers has to meet the manufacturer specifications, which 16 by 24 is a pretty good size vent, especially because you have two of them. And one other consideration is that the heat pump on the water heater will shut down to default to electric if those temperatures fall down below 36 degrees. So this could be whatever space you want it to be in that. But we're going to look at an example right here. So this is an actual install that we're going to share with you here. So this family wanted to install a heat pump water heater in an exterior closet less than 720 cubic feet. Now, one thing I want to point out here is that you see the heat pump water heater is sharing a wall on an interior room. So that while the door in this particular home, the access was on the outside on a deck, and it would open to the outside. If that were a solid wall and the door were moved to where the playroom and the heat pump water heater room share the wall, that would be another type of installation that we could address here too. But when I talked about those two closets, I was demonstrating there were exterior closets, this being an example of that. This could also be this could be a solid wall and not be an exterior closet, it could be an interior closet. Okay. Here's what's interesting about this. I talked about the multitude of things, multitude of approaches that an installer can consider when you have this kind of situation. And I counted 9 different ways to bring the ambient air in and exhaust ducting options. Okay. So so you see where the water heater is located. So one solution is simply to add full louvers to the door for intake and exhaust, like we saw in that closet inside the house. It's just a full louver door. Meets manufacturer specifications for net-free area, and it provides a space for the heat pump water heater to draw in outside air and to discharge the cool air. So that's one. We're not going to go through all 9 of these, but quickly I want to point these kind of differences out. A second approach is to add an intake louver to the door. So you have louvers for at the height of the intake grill, and then duct the air to the outside. Okay, so you put a duct on the side, discharge it out the side wall, or duct it into the playroom. Maybe the playroom gets a little warmer than the rest of the house. You can duct it in there and help keep that room more temperate. Another solution is to duct the ambient air from the outside. So bring it in from the outside and then exhaust it into the closet. You can just dump the cold air right into that closet without any louvers on the door. It doesn't have any requirement, but you do have heat loss there. Or you can duct it into the playroom to add the air conditioning. So we saw that where it was where there were 2 ducts, an inlet duct and a discharge duct. You could do that. Bring it in on the top, take it out on the side directly into the playroom. Another example, you could draw the ambient air from the playroom. So you duct it in from the playroom and then duct the exhaust air back into the playroom. So you can take it and just use the playroom as your source for air exchange. Another one is draw the ambient air from the outside and duct the air back out into the outside. So just the same as the playroom, draw the ambient air from the exterior closet through the wall, dip and duct it back out through the wall. I can go on for other examples, but you see what I'm talking about when you talk about the flexibility that you can actually have on installing a heat pump water heater in closed spaces. This is a fear of a lot of installers because what am I going to do to make this work? Well, this is a pretty simple solution, and we're going to look at it right here. So here's what this family opted to do. For the supply air, they brought in the conditioned air from the playroom. So the intake to the playroom, from the playroom. And their thinking was that the room is already heated and so it's going to be warmer year round, right? So the water heater would operate more efficiently. But then they also added louvers in the exterior door at the exhaust grill height, allowing the cool air to blow out to the outdoors. So it's only whatever the manufacturer's space requirements are, specs for net-free area. They put that louver in that door. They drew the conditioned air from the playroom into the water heater where it was already tempered and it's going to be that way year round, and exhausted it right through the door. Pretty clean install. And here's what it looks like in real life. So this is the completed installation on the left side. You see the water heater sitting there, and off the top of the water heater where they're drawing in the ambient air, it goes through that wall. Okay. You can see on the upper right side that's just simply a 90-degree, 3 foot of flex piping, 1 90-degree bend, and 1 8-inch to 6-inch reducer. And then at the bottom on the right, you see the finished intake grill in the playroom. That looks like a surround sound speaker. You know, it doesn't have any real impact on the way the room looks or anything like that. But it drawing air through that vent, through the duct into the water heater. And then if you look at the water heater itself on the left-hand side, you'll see right here is the exhaust, and it's aimed right at that grill or that louver on the door, just adjacent to it. So really a slick, simple install in a small confined space. So one thing about temperatures I want to point out is if you're in a room and the temperature drops more than 15 degrees, it's an indication of inadequate air supply in that room. The solution is to either add louvers, ducting, or both. What happens when the intake air temperature drops? So if that water heater is operating in a room that's 15 degrees colder than, if it has reduced its temperature 15 degrees, it could get to a point where it turns on the electric elements because the air now might be lower than 36 degrees, or it might be 36 degrees. So what's going to happen is that you could risk, if you don't have a big enough space or you haven't dealt properly with the air exchange, you're going to risk the water heater flipping over to the electric elements, and you're going to wonder why your bill was high. Well, because every time it turned on, it had to shut off the heat pump because it was drawing in too cold air. So that's the real measuring stick right there. If you're putting it in, go back to this one. If this room ever dropped below 15 degrees, because this is venting into that room directly, but it is aimed at the louvers. If that room dropped 15 degrees, you might have to duct it through there. Okay, the outlet duct. Okay, so it's blowing cold air, right? And it's often connected to the duct kit that comes with that you can purchase. It's an accessory. You have to purchase a duct kit, and the outlet duct is connected to that vent kit and a vent collar using hose clamps. Those just metal hose clamps that take a screwdriver that cinches it down tighter and tighter. Excuse me, tighter and tighter and tighter. To avoid condensation on those metal fittings on the exhaust side, you have to cover them with insulation and secure them with plastic tensioning ties. We just don't want to have condensation happening underneath or in that room on those metal fittings to cause problems. And so this is just tape can work, but tensioning ties pull that thing tight and prevents the warm air from reaching the cool air, or I should say cool air, the cool metal that duct is connected to the duct kit with. So the key takeaway here is, don't be afraid to design or install heat pumps in small spaces, but there are a lot of ways to consider the installation. So keep your options open and work with the family to decide how they want to exactly do that, how they want to accomplish that, but keeping in mind that You want to draw in ambient temperatures that are tempered, that preferably that are conditioned, or just on average. If you live in Florida, I guess, or Southern California, that's why you have those exterior closets, because it works down there. The temperatures don't fall, to too low temperatures very often. So just keep that in mind. Are there any questions about this section? Have anything, Diane?
Nope, nothing yet.
Okay. So we're going to move into installation consideration, location considerations. Okay, there's things about where you want to put a water heater to keep in mind when you're considering a location. We're going to talk about some clearance requirements and ease of maintenance. So let's get into that. Okay, what's the #1 barrier to heat pump sales? It's the cost, the first cost, the higher first cost. So installations where the heat pump can easily fit into the same space as the previous water heater will obviously bring the price way down. In these 3 examples, if it was an electric water heater that was replaced, the transition to a heat pump water heater would have been simple. There's no ducting, the condensate drain is there. There's just no real challenges to these installations. I can show you, I just want to share with you these pictures on the left. So you see this before and after. It's just a garage. Water heater is installed in the corner of a garage, and there's a before picture. It's an electric water heater that was replaced, and then there's the after picture. And essentially, that is the cat's meow when you talk about replacement scenarios. It's a very simple push-pull basic install. Little piping needs to be done in a condensate drain, and you're good to go. In the center picture, remember we talked about the laundry room being a good location for heat pump water heaters in most cases. Well, here's another example. So here you have the laundry facility, but you look at these doors, all the doors are louvered on the top, okay? So you have a really good air exchange built in right there. So the water heater has a drain, because you can use a floor drain, you can use a washing machine vent, a drain for a washing machine. You can use a sink. I don't see where exactly that water heater is draining the condensate, but it looks like it goes out of the water heater behind the washing machine. So I'm assuming that it goes into the washing machine drain. Real simple, clean install. And then finally, the picture on the right is a real good close example of the one we just went through that was showing the real life install. The difference here is that it's using a condensate pump to pump the water out of the room. So apparently might be a basement or something like that. It has to lift that water up to drain someplace else. But nonetheless, like for like kind of conditions are what you're looking for to help drive that cost down. If it's a gas to electric change, it'll likely require more extensive work, including electrical panel upgrade, perhaps. As we talked about last week, in 2023, we're going to see new incentives from the Inflation Reduction Act that was passed earlier this year. And in 2023, they'll provide incentives for these panel upgrades and for electrical work. So what might be a hurdle today in terms of first cost could be help that these new incentives will certainly help address that. So location consideration, look for the lowest cost install. That is your hurdle. Okay, noise level. So a heat pump water heater makes about the same amount of noise as a new dishwasher. They run about 50 decibels, so 45 to 55, somewhere in there. decibels. It's quiet, but if you aren't used to hearing it, it could be noticeable. So here's an example. I have this old mantle clock in my home that sits in my family room with my television, what have you. And when I have visitors, primarily my kids, they'll say, you know, how can you even hear that TV with that clock noise? So I just don't hear the tick tock that the pendulum makes, you know, unless I really listen for it. For me, it's white noise. So a heat pump usually turns into be similar for homeowners. It just becomes white noise after a while. You don't listen for the refrigerator kick on. You're not listening for the dishwasher to run. It's just kind of things that are, okay, it's in the background. I'm tuning it out. And in this case, I told you that the heat pump runs about 5 to 7 hours a day, so it's not constant. But eventually, the noise level kind of fades into your lifestyle or whatever's going on. But in some instances, there are considerations, so I want to talk about those. One of the things that you can do, if you're an installer or just somebody that's you know, an energy advisor or whatever, you can download this app onto your cell phone. It's called NIOSH, N-I-O-S-H. It's the National Institute for Occupational Safety and Health. And you can literally show a homeowner the decibel reading that's going on and how little sound it is when you are at 50 decibels. It just doesn't make a lot of noise, and it's hard actually to, even in a quiet room, to get below 50 decibels. But you can, it's a good way to demonstrate this is what you can expect from the sound of the heat pump as it operates when the compressor's on to heat your water. And usually, oh, is that it? That's kind of the reaction you get. So I would try to, for the sake of avoiding any kind of issues, if there's a way to install it away from a living room or living space or sleeping areas, not in the bedroom, you can help avoid being affected by the sound. Another thing is that earthquake strapping can transfer the compressor vibration to the studs, which can impact the adjacent rooms as well. When it kicks on, you might have this kind of sound going on in the adjacent room on the other side of the wall. Installers might consider securing the water heater in another fashion than just attaching it directly to the earthquake strapping directly to the studs. One other thing you can do is a lot of installers recommend installing a heat pump water heater, installing the heat pump water heater on a vibration pad made of rubber or neoprene or something like that to help absorb and reduce that vibration from the compressor. There's these kinds of things that you can do, but literally I'm telling you that in most instances it becomes white noise. Clearance. Okay, so there are no longer clearance requirements for heat pump water heaters. They used to have them. There is no longer they no longer maintain that requirement. None of the manufacturers. But creating this 7 inches around the tank for service is recommended. And there's a couple of reasons for that. If you need to turn a screwdriver on the back of that water heater, which you might have to do, because to access the heat pump, you have to remove the top shroud. And if you had a problem with it, I'm going to give you an example. There was a problem at one point with a number of motherboards, control panels. They're just simply, unplug and play. You unplug it, take it out, plug in the new one, and you're good to go. But you had to access the wires. And if your water heater is up against that wall and the screw happens to be back there, you can't turn a screwdriver. So what do you get stuck doing? You have to shut the water off, disconnect the water, and then move the water heater away from the wall. And in this case, you'd have to remove the you'd have to remove the earthquake strapping. All of that has to be done to get the water heater out there, so you can just turn a screwdriver. So it's really highly recommended that for the sake of service, that you keep that 7-inch clearance all the way around heat pump water heaters, or at least position it so you can access the screws on the shroud as they go around. I think there's 4 screws on most of them, but one of them is going to likely be in the back. I want to just share with you this particular installation. This has a couple of benefits. So what they did is they used this construction channel and some open-ended lag bolts and some all thread, and they were able to secure that water heater 7 inches away from the wall and eliminate any vibration that was being transferred into the house, because it's also sitting on a shroud, or on a neoprene mat that allows all that vibration to be absorbed elsewhere. So this is just a really slick, clean way to do it, and I share this with installers because this is creative. It's a nice way of providing clearance for the water heater. One other thing to point out: at no point do you want to aim the discharge at the wall, directly at the wall. That air needs to move away from that fan, and make sure. So you just want to make sure that you twist it a little bit. Just position it so that the discharge air doesn't blow directly into the wall, bounce back into the fan that's creating this air. Here's that kind of the question somebody asked earlier about locations on the impact on HVAC system. And I don't want to overplay this, but this is something to keep in mind, okay? Heat pump water heaters, they are small air conditioning units, and in larger spaces have virtually no impact on the HVAC system. There's been tests or research done on these, and it might be 1 to 2 degrees impact in a space, but if it's a large room, it just blends in with the other air that's in the space. It's not noticeable. If you're located in a heat pump water heater on an interior room, though, you want to be sure to discharge the outlet so that it's not aimed at a thermostat. This is kind of no-brainer right there. You're going to be blowing cold air that's had the heat removed from it onto the thermostat, and depending on the season, the cold air will signal the furnace either to come on, or it'll tell the air conditioner to shut down, because it's going to be colder than the air that's going to be coming through your air conditioner. But generally, just as the warm air blowing into your kitchen from your refrigerator has little impact on your HVAC system, the heat pump will likely not have an effect on the system either. Ease of maintenance. So we talked a little bit about putting water heaters in the same space as the previous water heater. Sometimes that means an attic. Okay, I'll tell you, well, first of all, these things are not light. They are heavy, ranging from 220 to 260 pounds. And to hoist that puppy up into an attic and put it up there is going to take a couple of big old boys, I'll tell you. It's just going to take some real hard work. So a situation like that, or if it's in a crawl space, the same kind of thing. Unless it's open, you can wheel it around in the backyard, and maybe the house is built on a slope and you have a space there. Regardless, if the heat pump is tucked away in locations like attics, crawl spaces, and even some closets, it kind of creates this out of sight, out of mind scenario. And these are hands-on appliances. So we want to make sure that the homeowner can keep an eye on the heat pump water heater. When I say hands-on, we talked about you can adjust these, you can program these things to go on and off during whatever season you want and use whatever means you want to heat the water. So you want to have access to it. But if it's up in an attic or away in a far away space where you can't see it, closet maybe, first of all, it has the control panel, okay? And on the front of that control panel, as you see there in the diagram, it will display error codes if there's a problem with the heat pump. So in some instances, it'll display that the heat pump is not working. Maybe the condensate drain is plugged, okay? If you don't see that, if you're not notified of that, then you're going to operate that water heater on electric elements until you figure it out. You're going to wonder why your bill in the month of November was triple what it was in the month of July. I mean, seriously, it's just like, wow, something's wrong. Well, that's why you want to have these things where you can visually see the thing. So those error codes will show up. Also, in some cases, if there's a serious issue, an audible alarm may sound, leaving the homeowner kind of searching for the source. If it's up in the attic and you hear this, where's that coming from? You're going to send somebody up a ladder into the attic to figure it out. So it's just not a good solution for having them out of sight and out of mind is not a good solution for locations. Also maintenance. So just having a clear view of the water heater would be the most desirable. And there is some routine maintenance on a heat pump water heater that needs to be considered as well. So the filter, so it's drawing air in, right? We talked about the air, the fan blowing air across that evaporator coil, drawing air in. So whatever's in the air has to be filtered out. So it has a filter on there that will keep the incoming air clean, but it'll get dirty. And over time, it needs about, depending on what you have, what activities you have going on in your garage. If it's just kind of a place to store food and park your cars and your lawnmower and what have you, probably not a big issue. But every 3 to 4 months, maybe every 6 months, you have to check that filter. Your air code will pop up to tell you that it's not. You need to clean the filter if it's not getting. If you haven't done it routinely. But if you have a wood shop, different story. You might have to keep it. You might have to clean it monthly, depending on what kind of vacuum system you have. So the top of the water heater is where that is located. So you have to be able to lift that out. So you can't put shelving right on top of the heat pump water heater because you'll have to raise that up. So it's going to be 6 to 8 inches of clearance on the top of the water heater. That would be necessary to remove it. Then you just clean it off, put it through the dishwasher, run it through the sink, whatever you use to clean it, dry it off, and put it back in. Other maintenance is kind of standard for other water heaters. That, as with any water heater, you have to flush it annually. Any service work that needs to be done under that shroud, don't forget, will require access to those screws. So you don't want to, if you want to replace the anode rod, or like I said, the plug and play controller, or say you have a clogged drain pan because you've been running a wood shop in your garage. Whatever those reasons are, you need to take that shroud off and then lift that off and then take care of the issue. So you want to make sure that you have that space available. You can turn that screwdriver. Here's the example I just spoke of. If your water heater is located in your garage, but you're also using using the space for woodworking, be especially aware that that filter will become clogged more often than otherwise. And if it's left uncared for, that will not only collect in the filter, but the air continues to flow across that. The drifting sawdust that's in the air could collect on the evaporator coil and get that all gummed up, and could also settle in the condensate pan and plug that. So dusty conditions could cause the drain pan to block, and then you got another issue. So it's just wise to keep that. In this particular case, you can see that the homeowner has installed a vacuum system to collect the dust from woodworking, and without a system like that, you would have problems with the heat pump. So the key takeaway is there's an installation solution for any location, but there are locations that are just not practical for heat pump water heaters. Any questions?
No questions.
Right. Either I'm covering all the bases, or you're just not interested in learning about, or not given the chance to answer your questions. If you do have questions, please put them in the chat, and we can either get to them on this training, or I can address them later. Katie can send me.
I think they're just shy.
Shy, yeah, probably. Okay, going on now to managing condensate. So where's the condensate made? When and how much condensate is produced? How do you remove the condensate? The pH, acidity of condensate, and the code for condensate. So we'll go through these things and see how what we can talk about here. So as the warmer ambient air passes over that evaporator coil that has the refrigerant in it, it's cold. It's been before it gets compressed, it's a cold refrigerant, -50 if you recall. The humidity in the air will build up on that coil, just as it would a glass of ice water sitting on your coffee table. Okay, on your coffee table, you have a coaster that'll capture the moisture that runs off your glass. But in the case of a heat pump water heater, the water falls off the evaporator coil and into a drain pan, where it then is drained away from the unit. And that's where that all takes place in that picture there, in that evaporator coil. Remember, we talked about the dirt and stuff like that. If stuff gets past that filter, can you imagine having to clean that coil off? It would really be a mess. So that's why it's critical about keeping that filter clean. Okay, so this is how it looks inside the heat pump water heater. You'll notice that the drain pan underneath the evaporator coil has a slope that falls slightly downward toward the drain opening. Okay, this prevents any stagnant water from building up inside the pan and ensures that pan will drain, that'll fully drain. But that'll collect water. Typically, a heat pump water heater will produce between 1/2 to 1.5 gallons of water a day. So it's a significant amount of water. Just depends on the humidity, actually. If you're in Florida, that would be a lot more than 1/2 to 1.5 gallons a day. It'd be considerably more. I don't know what the amount would be, but we've seen that in our environment, it's typically 1/2 to 1.5, depending on the humidity. So you can see where the condensate drain is there. So what you want to make sure that you have happening is that water heater is installed on a level base, on a level pad. Whatever you're putting it on needs to be level in order for the slope on that drain pan to properly drain that condensate away. So there's some instances where condensate won't be generated, and if the ambient air temperature is below 36 degrees, the heat pump shuts it down, right? So it stops producing condensate, so just to avoid freezing and blocking the drain line. Another time when it won't produce condensate is when it's operating on electric only mode. The heat pump never turns on during that mode, so no condensate. Another situation would be if there's a plug in the drain pan or the drain line. So think about that wood shop scenario in the garage. If that was plugged, then the heat pump would shut down and it would flip over to electric elements. We had one instance, gross, but I'm going to tell you, where that drain line, that the condensate drain went down to the ground and went into a floor drain, and a mouse crawled up in there and it couldn't get its way out. So installer had to come in and clean that drain line and discovered this dead, rotten mouse in there, and talk about disgusting. So nothing you can do about that, but I would try to set that up so it doesn't have an open-ended access to crawl up inside there. That was only a one-time occurrence that I've ever heard of, but it was funny, and so I always kind of joke about it. Another instance when it won't produce condensate is if there's a problem with the heat pump. So the issues that might occur with the heat pump itself could stop it, and it'll give you an error code that'll tell you what the problem is. One other point that I want to just share with you is you can see in this diagram, or not the diagram, in the photograph on the right, that the condensate is draining right next to the foundation of the house. It's not advisable to drain a condensate right along the foundation of your home. Try to direct it away from the home using like French drain or something like that. It's not a lot of water, but having it at the foundation is not the best solution. So just moving it, 3 feet away from the house, you can drop it down to the ground and take it underground, and it will be just fine. But I wouldn't want that area of my yard or my foundation wet 24/7. So that's what you get. Okay, I talked about this real briefly. Because the drain pan is sloped toward that opening, it's important that the water heater be level, or otherwise it won't drain properly. So condensate removal, here it says 1/2 to 1 gallon of non-acidic water per day. I would say that it can get to as high as 1.5 gallons in more humid summer days. But it's okay, it's non-acidic. So depending on the relative humidity, the more you'll get. Okay, we already mentioned that, but there's three ways to dispose of condensate. One is to tie it into an existing air conditioning or furnace condensate line. All the high efficiency furnaces and air conditioners today, they all have condensate that they have to deal with, and if it's located in a garage or some other location, it'll have a condensate line that's going somewhere. You can gravity feed it to an existing drain, as you can see in this photo. That might have been the one where the rat crawled in, or the mouse crawled into, I don't know. I'm kidding. I would make sure that drain is sitting down on top of that, or that drain line is sitting down on top of that floor drain to avoid any animal crawling in there. But not only can they go into the floor drain, gravity can feed into a laundry tub, a washing machine vent, as we spoke about earlier, any of those places where there's already a drain in place. And homes on slabs or with basements without a floor drain, you could add a condensate pump and pump it to the outside. So there's a lot of different solutions to get rid of the condensate. It's one of these changes that plumbing installers don't have to do today. Well, they do have to do them if it's a gas water heater. So gas water heaters have condensate, but it's a different kind of condensate. We'll talk about that in a sec. Condensate pumps. So the amount of condensate, I guess, I'm going to repeat myself, is dependent upon the amount of moisture in the air. So typically, a 2 gallon per minute pump is sufficient to remove any water that's generated from the heat pump and the HVAC system. And you can see the example in this photo on the right where I've circled the condensate pump. It's hard to see, but it's down there. But what's interesting is that they have tied their temperature pressure relief valve into the existing HVAC drain, be pumped away by the condensate should it condensate pump if it should, go off. That's not a standard. I've not seen that before, but it was the only picture I could find where one drain line was tied into the condensate drain line of the HVAC system. But if that pump is capable of moving that much water, if that valve goes off, I don't know what the volume would be, but it would be probably pretty significant, unless it's just got a leak. But anyway, that's an example of how this could be done. So you have an HVAC condensate drain from the coil inside the unit itself. You can see it there, and goes down into the condensate pump. If the heat pump is installed in a basement, the pump needs to be capable of doubling the required lift. So lift is the height that the water needs to reach the drain. So if it has a limitation of 8 feet, for example, the lift of 8 feet, you'd have to get a lift that has at least 16, because you could easily have 8 feet from the floor to the ceiling in a basement. So anyway, the run, meaning the distance the water has to travel horizontally, should not exceed 50 feet. So the run does not affect the lift or the flow rate of the pump unless it exceeds 50 feet. So just some technical stuff, but that nonetheless, these are pretty standard kind of features about heat pump, or excuse me, about condensate pumps, that they just need to be able to double the lift if you're going to put them in a basement, and then the run can't exceed 50 feet. Talked about the pH. In a standard gas water heater, the water vapor generated during combustion is vented to the outside as steam. But in a condensing gas water heater, tankless water heater, some tank water heaters are more efficient. The combustion gases are cooled off. They're capturing more of the heat, reducing the temperature, and forces the water out, cools it down to a point where it becomes a liquid. Liquid byproduct resulting from that action, from the condensate from combustion, is acidic, and it requires by code that it be neutralized. So no need to neutralize the condensate from a heat pump water heater. As I said earlier, it's the same water vapor that collects on a glass of ice water. I wouldn't drink it, but it is non-acidic. Early on, some inspectors challenged that thinking, that the water from a heat pump water heater was equivalent to combustion condensate. So the manufacturers started adding notes in their manuals to offer that clarity. In fact, I think I ran into that up in your neck of the woods in Everett, I think is where it was, where the inspector wanted the installer to neutralize the condensate. And he said, well, it's the same as a glass of ice water. There's no acid infused. So you can see here on the picture, on the range, on those colors, that the difference between combustion, the condensate produced from combustion down there by lemon juice or to wine, compared to a heat pump water heater, is neutral. It says equivalent to distilled water. So the inspector finally reneged and found out that it wasn't the case like it was for gas, and so they allowed the installation to go without it. Okay, so there's an international mechanical code, 307.2.2, has specific requirements for condensate lines. So I'm just sharing this with you because these are kinds of things that are of interest to installers, but may not be so much for anybody else, but I don't know who's in the audience, so I'm going to go over it. So condensate lines, first, the diameter, the inside diameter can't be smaller than 3/4 of an inch. So it can't be whatever the diameter of the drain pan outlet diameter is, it can't be smaller than that. Next is for every 12 inches that the condensate line travels horizontally, it has to fall a minimum of 1/8 of an inch. So when you're talking about that run, we're talking about you're going to have some kind of fall. So that pump has to get it up there, and so actually, as it travels horizontally, it could drop. The PVC, the support for PVC pipe, every 4 feet it has to be supported on horizontal runs, and every 10 feet on vertical runs. The condensate line must be installed so that the line can be cleared of any blockage without cutting the line. So this is that story again, going back to the mouse. So the installer had to clear that line without tearing that condensate line apart. So a solution for that is placing a T rather than an elbow at the start of the condensate line as a way to achieve this. Here's an example of it right here. So on this heat pump water heater, at the top of that condensate line, they have a T installed, and you can remove the top of it and then run your wire brush or whatever your cleaning tool is through that condensate line to clean it out if there's ever a problem. So the key takeaways is condensate will only be created when the compressor is running. And the condensate from a heat pump water heater does not require a neutralizer and can be disposed of into an existing drain, an existing HVAC condensate line, or can be pumped outside. Okay, any questions on that section? So I'm going to move on here to this section, sizing. I'm going to move through this quicker because we had a summary of this sort of last week. How to maximize savings, sizing tools, and recirculation pumps. Okay. So in order to get the maximum savings from a heat pump water heater, it has to be the primary means. The heat pump has to be the primary means for heating water. I know we all agree on that. That's why people buy them, right? So they get the efficiency. So the compressor, when the heat pump water heater is operating, when the heat pump is operating, will use only 300 to 550 watts of power, depending on the brand that you're purchasing. One element will use 4,500 watts per hour. So that makes the heating the water with a heat pump 8 to 15 times more efficient than using the elements. So owning a heat pump water heater that is properly sized allows the homeowner to draw all the hot water they need without triggering the electric elements to turn on. The slide on first hour rating now. In this case, the first hour rating points to the first top on the picture points to this would be an electric water heater. The first hour rating is 62 gallons. Okay, so when we talk about that, if there's one complaint that a heat pump water heater owner makes, it's because they're not getting the savings that they expected to get, and it's always because the water heater was undersized. The electric elements are doing the work. It is basically an electric water heater if you don't have the right capacity up front. Think about how they work. As the hot water is drawn out of the tank, cold water is introduced to replace that hot water. And as this happens, mixing occurs, which lowers the overall temperature inside the tank. As that temperature decreases, the sensors will call for more energy, whether it's gas or electric, to begin reheating that water back to the desired temperature. So in the case of an electric water heater, the elements come on full on, and if it's gas, the burner fires up. So when we decide on what kind of water heater, the size of the water heater we want for our home, there's a couple of methods that they use. And this first one is the first hour rating. The drawback is that it uses all of its energy resources to reheat that water. That's why it's faster. That's because it's using 4,500 watts of power to get that water heated after the system calls for it. If the water heater is a heat pump water heater, though, the heat pump will come on first. But if it senses that it's not able to meet that demand, it will turn on those electric elements, making it an electric water heater. So they have the same first hour rating, a heat pump water heater and an electric water heater, because if you use all of its energy, you're going to have both of them are going to be heating water with a 4,500 watt electric element. Okay, we don't want that. That's not our objective. So we agreed that when we buy a heat pump water heater, that we are trading speed for efficiency, right? If you constantly need hot water during the morning rush hour when everyone is trying to get out the door, that period, whatever that period of time of the day is, it's known as the peak hour demand. So the peak hour demand is a better way to properly size a heat pump water heater for a family if your goal is to reduce your water heating costs. The peak hour demand, if you recall these two examples. So in the case of the example on the left, where you take the number of bedrooms plus 1 times 12, using that example that I put in below, you have 3 bedrooms plus 1 is 4 times 12 gallons is 48 gallon peak hour demand. On the example on the right, you have average gallons of hot water per use. So if you have a shower, a bath, you're shaving, whatever the activity happens to be, it has an assigned average consumption of hot water. So if you assume that there's 3 people in this example, go down to below and you see the example, it says 3 showers times 20 gallons is 60 gallons, 1 shave, 2 gallons for 2 more gallons, 1 shampoo, 4 gallons for 4. You have a total of 70 gallons during peak hour demand. Both houses have 3 people. So neither of them, one seems to be a little light on the number on the demand, and one seems to be a little heavy. But here's what you got to think about. When you see models, heat pump water heaters come in 3 sizes. They come in 50, 65, and 80 gallons. So the equation example where there's 48-hour peak hour demand, would you buy a 50-gallon heat pump water heater? No, you wouldn't, because the water heater will only provide 70% of its capacity as hot water. The rest of it will be mixed with cold water that's introduced. So a 48-gallon peak demand would require a 65-gallon heat pump water heater. And what that would do is then provide you with enough capacity initially, and then the demand falls off, that it doesn't require the elements to come on, because everybody's left the house, gone outside, gone to work, school, wherever, and now the heat pump kicks in and it's not sensing any further demand. So it will it'll chug its way through heating that water through the course of the day. 9 gallons an hour will replace it, 9 to 12. In the case of the other example, it came up with 70 gallons. Well, the largest heat pump water heater they make is 80 for residential applications. So even in an 80-gallon tank, you're not going to be able to meet that peak hour demand if it's really, in fact, 70. I think it's heavy, really heavy, for 20 hours or 20 gallons of hot water for a shower. Seems to be pretty steep. But nonetheless, this also, it doesn't take into consideration any water conservation measures. So I think that that could be adjusted downward, and an 80-gallon tank would suffice. So anyway, those two things, what the point of this is that in both cases, you want to have enough water heater stored up, hot, ready to go during the peak hour demand, and not rely on the first hour rating, which will drain the tank. Remember that water heater that in the first hour rating? The first hour rating only had a 62-gallon capacity. Well, and then that's with an hour-long wait period after you've drained it down. So in this case, you have, even in the 48-gallon peak demand example, you already have 65 gallons sitting there ready to go. And you can draw on that and take your showers and do the things that you need to do without ever triggering those elements to come on. So big point about sizing, and it's a challenge it's a big challenge because the initial assumptions were that if you had a 50-gallon electric water heater or a 50-gallon gas water heater, you would replace it with a 50-gallon heat pump. No, you don't replace it with a 50-gallon. You go up one size and oftentimes two sizes. Here's the rule of thumb established by NEA, Northwest Energy Efficiency Alliance, for our region. 2 people, 50 gallons, three adults, 65 gallons, and 80 gallons for up to 4 adults, or two adults and 3 children. I would use this as my measuring stick because this has been tested and proven, and we think that it's the most accurate way to determine, without going through those peak hour demand exercises or using the first hour rating to establish a proper size for the home. We don't have many of these, but they are out there. I used to live in Gig Harbor, and I had one in my house there. It's not at all popular, but some manufacturers of heat pump water heaters discourage uncontrolled recirculation pumps. Uncontrolled pumps, they can actually waste about 3,000 kilowatt hours a year. The penalty is high on heat pump water heaters because what it does is it circulates as the hot water circulates through the house to make it available at any tap on a moment's notice. It cools down as it circulates through there and then goes back into the water tank to be reheated. Well, what that does is it tells the heat pump that it's not able to keep up. And so what happens is it flips over to the electric elements to try to keep up with that demand that it thinks it has, but it's actually just circulating. So the solution to that is one of these like smart plugs. The plug requires no plumbing or electrical work, and to install it, you just unplug the recirculation pump, plug it into this smart plug into the wall, plug the pump into the smart plug, attach a thermistor to the hot water line, and the smart plug learns the water draw patterns of the household. And what it'll ultimately do over time is it'll turn on like 15 minutes, circulating pump will turn on 15 minutes before the hot water is needed, and then it'll shut off when the end of that peak hour period, or whenever it senses over a course of a 24-hour day, whenever the demand is high, it'll turn it on in advance. But it won't run all the time. These uncontrolled recirculating pumps are not a good thing to have on a heat pump water heater. The takeaway is upsizing the heat pump water heater will provide greater capacity initially to meet the peak hour demand, allowing the heat pump to do most of the recovery. Any questions? I'm bumping up against our time. I just want to move through. I better just move on here really quickly, wrapping up. We're going to talk about the panel upgrades, average costs, fusible disconnects, and incentives. I'm going to be quick about this. 31% of the homes in Seattle City Lights service territory use natural gas for their water heating. It's about 12,000 water heaters a year. So when switching from gas to an electric water heater, generally requires a panel upgrade that will provide 240 volts So you have to have that available to you. In a planned replacement scenario, installers should encourage customers to upgrade their electrical panel first and provide the space for electric vehicles or anything else that they might want to do. If an installer doesn't have an electrician on staff, they should partner with one, because you should bundle those services together in those cases. And you can quote the job with electrical work as well as the plumbing work. Here's the average cost for panel upgrades. Now remember, we have these incentives coming. You're going to have a 200 amp upgrade most likely, so you're going to expect to spend between $1,300 and $3,000 on a panel upgrade. It's not always the case, but that's generally the case. This is a fusible disconnect. So I'm not an electrician, but you're encouraged to check with your local jurisdiction regarding this code. But they require, the electrical code, the National Electrical Code requires that a shutoff. When someone's working on a electric water heater, it needs to be assured that the electricity will stay off while they're handling those wires, right? Because it'll kill you if you get shocked. The building code addresses this by putting these safety measures in there. And one of the safety measures that they have is called a fusible disconnect. So that means that the panel has to be within sight. So if the main electrical panel or the sub panel that serves the water heater is directly within sight, a second means of disconnect is not necessary. So the National Electrical Code defines within sight as being a maximum of 50 feet away. So if the water heater is in the garage or the utility room with a direct sight line to the nearby panel serving it, that would be acceptable. It's when the code specifies within sight means in both directions. So the switch should be visible from the appliance and the appliance visible from the switch. So if the switch is just around the corner from where the water heater is located, and you can see the water heater when you're standing at the switch, but the switch itself cannot be visible when you're standing at the water heater, it's not acceptable. So you have to put in these disconnect at the appliance, and I've circled them here to identify what they look like. Okay, we talked about panel upgrades. This is the virtually the last slide. Bream has come out just this year with what is called a ProTerra 120 volt plug-in heat pump water heater. It's an easy gas conversion. It just requires a regular 110 or regular wall outlet. It has the same heat pump technology. It has time of use scheduling, all those energy savings features. It has Wi-Fi, so you can control it. It has the vacation mode. It reduces your carbon footprint. And this makes a gas water heater replacement really simple. It doesn't work as fast. So we talk about 9 gallons an hour. This might go down to 7 gallons an hour, or even 6 gallons an hour. I'm not sure what their recovery rate is with using the heat pump, but nonetheless, if you have a small family, 2 or 3 people, this might be a solution to avoid those expensive costs of adding, upgrading your panel. But with the new Inflation Reduction Act of 2022, those panel upgrades might be less expensive. So there's those eligibility requirements that you need to be familiar with. Since you have access to this presentation, you can read them here. Those are just really rich, and it's these kinds of incentives that will move the market and move it quickly. In addition to that, the advanced water heater initiatives coming into play, and you're going to have additional focus, training, and everything for people that are involved in the market that can impact the sale of heat pump water heaters. Knowing this is going to be really critical. So you're going to be upgrading in the incentives considerably. Jules has at the sign lights, or at the sign light, she can provide you with some specific details about this if you'd like to. Okay, this is the last slide. I'd like you to help me out here. Rank from 1 to 6 what section of overcoming installation challenges did you find most helpful? Was it the heat pump technology overview? Was it the space requirements, the location considerations, managing condensate, sizing, or switching from gas to a heat pump water heater? I know there's a lot here, but if you can give me some sense about what you found valuable and useful in your work, that would help us to strengthen our presentation going forward, I'd appreciate that. Do we have any questions out there to wrap up?
No, we're good to go.
Okay. Good. Anybody out there that can add your thoughts, I would appreciate this. So the louvers and ducting seems to be the most popular noise, the location consideration, sizing, managing condensate. Well, go ahead and put one more person gonna rank.
This was a really great presentation, Tim. I really enjoyed it. Not as many people showed up today as they did last week, and they missed out. I'm glad we recorded this for them. I have a couple of colleagues that I'm going to recommend go and watch this recording. I really thought this was great.
Great, thank you. Is this Katie?
It is, yeah.
Oh, okay. Yeah, I appreciate that, Katie. Well, for anybody else, I'm always happy to answer questions you might have going forward. You can reach me through our DNR Learn website, or just send Katie a note and be happy to help you. But if there's no other questions, we'll just move on from here. But thank you so much for your time. And like I said earlier, if you're looking for continuing education credits, reach out to Katie. I'll get her the right paperwork so that you can, or just actually just a little bit of information that they look for you, and then I'll forward it into the Labor and Industries facility and get you covered.
Yep, and I put just write to lightingdesignlab@seattle.gov, real simple, and get in touch with me, and we will go from there.
Wonderful. Thank you, everybody. Again, I look forward to hearing more from you. There's a lot going to be happening in this market, and I'm glad that you're taking the position to be proactive in addressing it, because it's going to be a big deal.
It really is. Thank you, Tim and Diane, and everybody. Have a great day.
You as well. Thank you.
Bye-bye.